Good morning, everybody in the lecture hall. Good morning, everybody on Zoom. Good morning, everybody watching us from the future. Today, I'm going to finish what we started last week, which is a practical part on SQL with a bit of more advanced features, and then we'll continue with database design theory. It's scary, but it's just mathematics. So it's going to help you make good design if you design relational tables later for a company. So I'd like to start with a question, as we often do, to test your knowledge. So which expressions do not return unknown? Some of these return unknown, some of these do not return unknown. Remember that this is about three-valued logic in SQL, true, false, and unknown. I'm giving you the top, the record on which this is evaluated. On the top right, price 23, name null. And if you evaluate the predicates, that would technically be in a where clause, these four predicates, which ones return true or false and not unknown? Multiple answers possible, of course, right? I'm going to make you a co-host, Marcin. There you go. Yeah, you should be one now. So now we have a few responses. Okay, so let me show you the answers. These are the correct answers. So it seems here the majority was not correct. So let's go through them. So the easy one is the third one, right? So you all agree the third one is unknown. Name is null, so we don't know what there is in there. Name equals foo, that's unknown, and not unknown, that's also unknown, right? Who agrees? Right? Okay, so the third one is unknown. The last one is also easy because name equals foo. Yes, it is unknown, right? And the is unknown test is going to tell us true, right? Who also agrees? There was a majority here, right? And now it's the first two that the majority did not get right. Do you agree price smaller than 22? That's false, right? That's false. So price lower than 22 and anything, false and anything, do you agree it's always false? Right? It doesn't matter what name is. The moment you have something false, price lower than 22 is false, you can do and with anything you want, it's still going to be false, right? Okay, like if I say, I am the president of Switzerland and you don't hear because I'm coughing the rest that I'm saying, then it doesn't matter, you know that what I'm saying is false, right? Then the first one, we have false or something. So now imagine I'm saying I'm the president of Switzerland or, and then you don't hear what I'm saying next. Then you don't know if what I'm saying is true or not, right? Because false or something, false or unknown, you don't know, right? That could be true, that could be false, and that changes the result of or. Who agrees with that? Right? Okay. So really do this mental exercise of imagine somebody who is telling you things and the unknown, imagine that you don't understand, it's unintelligible, the moment that is in unknown, and ask yourself, can I still guess if the result is going to be true or false, not knowing that part, right? You can also try to replace it with true and with false and see if it changes the result. False and true is false. False and false is also false, so it's always false. False or true, that would be true. False or false, that would be false. So then that would be unknown. Okay, so that was the question right here. Now the next question I have for you is if you look at this query right here, select from where with a join inside the from clause, which we covered last week. I would like you to tell me what it is using wordings of the relational algebra. Right, so what is this doing? What would be the query plan using the relational algebra? And so I'm giving you a few possibilities here. Was that an inner join combined with two selections? Was that an inner join followed by a selection and a projection? Or was that a full outer join combined with a selection and a projection? Or was that a natural join combined with a projection? So I had a select from where, and in the select from where, in the from, there was a join. Right? I can show it again right here. Right, so this is the query. Select from where, I'm just saying join on. Right. So basically, is that an inner join? Is that a full outer join? Is that a natural join? And do I do a selection and a projection or just two selections? These are the what you need to figure out. I'm going to alternate a bit between the two. Let me show it again. Is that a selection and a projection, or are these two selections? Is that a natural join? Is that an inner join? Is that a full outer join? We're basically connecting what we did 3 weeks ago with what we did last week, right? In terms of the part on the relational algebra with the part on querying with SQL. You see that, you know, there's tutorials of SQL online and anybody can learn SQL. But if you learn SQL knowing the relational algebra, that's more powerful because you really understand the structure of what is happening behind the scenes. Okay, so I'm going to now display the answers, which should normally show up now. So we have a majority, and the majority, if I click, is correct. Well done. Indeed, it is an inner join because if you just say join, that's not an outer join. If you want an outer join, you need to explicitly write left, right, or full outer join or just join. But you need left, right, full to make it an outer join. So it's an inner join. It's not a natural join because you would have written natural join if it was a natural join, and we didn't have the keyword natural in the query. So it's an inner join. If you just say join, it's an inner join. Next, is that two selections or a selection and a projection? Well, you can see the selection is in which clause? That's the trap, yes? The where clause. The selection is in the where clause. The selection is not in the select clause. That's the trap. And in the select clause, we have a projection, that's pi, on name, price, discount, and customer, right? So pi, the select clause, sigma, the where clause. So this is why we don't have two selections. We have a selection and a projection, all right? So very happy to see here a majority, right? So this is a way to connect SQL with the relational algebra. Okay, and now that's a recap of the clauses we've seen. Take a good snapshot of that. You really have to know this by heart. Select, from, where, group by, having, order by, limit, offset. Always in this order. They're optional, right? So select, of course, has to be there, but most of them are optional. Having doesn't make sense without group by, limit and offset don't make sense without order by, right? But this is the order. You really need to know that by heart. Who knows it by heart already? So try to take 1 or 2 minutes, repeat it, try to not look at the side and repeat them to you. It should really be something that becomes natural to you, this order, right? In modern systems, like in big data, we actually relax the order of these clauses to something much more powerful and generic. Google made the move with what they call the pipe syntax in BigQuery, but the standard SQL is really in exactly that order, okay? Who is comfortable with a query like this? Reading it, right? So what does it do? We have a table persons. That has cities and populations, and so city and people with first residence, second residence, and we filter only the first residences. That's the where clause. Then we group by city. So then we're going to get some outputs with a list of cities. You notice that the key in the group by is also in the select. You should always do that. The grouping key should also be in the select. So city, city. So now we have plenty of cities. But I'm only taking those for which the count is less than 100,000, right? So the smaller city, there wouldn't be Zurich, there wouldn't be Geneva, right? Then I order by population descending, meaning that I'm going to have the largest cities below 100K and then smaller and smaller and smaller. And I'm outputting the city with its count. So it's going to be descending counts. And limit offset, do you remember what that does? That's going to paginate, right? So we take a limit of 10. So with the offset of 20, we are going to be a page of 10, a page of 10, a page of 10. Which page are we printing if we say limit 10 offset 20? The first page, the second page, the third page, the fourth page of 10? The third, yes, absolutely correct, right? Offset 0 would be the first page, offset 10 would be the second page, and offset 20 would be the third page. Who now understands this query based on my explanations, right? It's absolutely fundamental. This is really something that you have to make sure you're comfortable with. You can play with it. You can write queries. You can do without group by and having. You can do without order by limit offset. You can do without the where. So that's it. That is the core of SQL. Yes? The on. That would be a theta join, right? So the theta join is the join that has a little predicate. The natural join would just take the columns in common, right? But the theta join, you make the predicate explicit. So it's a mathematical formula, right? So it's basically a theta join whose predicate is that you take the tuples from these two tables, products and sales. You only keep those for which the product's ID, so PID means product ID, so the product's PID matches the product that was sold, S.product, right? So that is a theta join. So imagine products, this little character, with that looks like an hourglass, a horizontal hourglass, subscript PID equals support, right? And then sales on the right. Do you agree? Right? So that is a theta join. And actually, I even brought a recap slide exactly for this, so to remind you of this. Of all the possibilities, so this is all in the from clause, right? We saw this last week. Cross join, that's the scalar product. What am I saying? The Cartesian product, right? Cross join is the Cartesian product. Very dangerous. Avoid it, right? You really need to be very careful with that one. I put it in gray because you can just put a table, comma, a table, comma, a table. That's going to take the Cartesian product. Then we have the inner join where join is enough. Inner, you can write it, but it's optional. Left outer join, left join is enough. Right outer join, right join is also enough. Full outer join, full join is also enough, right? So these are the kinds that you can do, right? And for the ones that are not Cartesian products, so the last four, if you forget about the Cartesian product, you have three possibilities. First, natural. Natural is going to just look at the columns that have the same names on both sides and match on that. The on clause is going to be the theta join. That's when you explicitly say which predicate you want to join on. Very often it's going to be equalities, but you might have people who want to have greater than or lower than. I mean, this is a bit more complex and long to compute, but this is any formula I want to put in there. And using is just a list of attributes. Using is very practical when you basically just want to equal columns, to take values that are equal. But you have accidental column collisions. You basically have two tables that you would like, in principle, to do a natural join with, but they have a few column names in common that you don't want to join on, right? So in that case, instead of natural, just say using, and then you put the names of the attributes that you would like to join on. Okay, that's basically a fixed version of the natural join in case of accidental collisions of column names. For whom is that clear? Okay. For whom is that not clear? Don't see any raised hands. You know, I can explain and re-explain. That's exactly what I'm here for, right? So do not hesitate if at any point anything is not clear, even by email, even on the course forum. Okay, so that was a recap of what we did last week. So now I can tell you a few more things. Again, you remember in the relational algebra, I told you can compute the union, the intersection, and the set subtraction of tables, right? Because tables are sets of maps. So I can do that in SQL. It's actually pretty easy. It's pretty easy. So you remember that's the union of two tables. Who remembers that? Right, that's the union of two tables. That's how you do it in SQL. Very simple. You have a select from, it could be a select from where, group by having, order by, limit of set, of course, and then union, right? And then again, select from where, group by having, order by, limit of set. Right, I keep repeating it so that you really remember it. So you just say union with a select on the left and a select on the right. That's how you do it. Be careful, this is going to eliminate duplicates. Right? It eliminates the duplicates. That's the set semantics. If you would like a back semantics and you do not want to eliminate duplicates, that's easy. Just say union all, like this. If you say union all, then it's going to keep, in that case, there's a duplicate. And it kept the duplicate being a duplicate because of union all, right? Bag of maps. Then we have a bag of maps because the same record occurs multiple times. Right. So union or union all, set of maps, bag of maps. Who is with me? Right. That's easy, right? You just say union between two select from where queries. And then the others are easy too. You just say intersect if what you want in the intersection. So you can see that these two tables have only one record in common, which is the C. This one in here and this one in here. These are the only records that fully match. And if we say intersect, we get this result. Who agrees? Right? And finally, the set subtraction, that's except, right? So a select from where, except another select from where. And this is going to basically output the records in there, except those that are in here. So it's going to remove this one. Enterprise C is going to be removed because it's in there, right? So it's ABC except C gives you A and B. Who is with me? Right. Do you see that intersection all and except all doesn't exist? Right? That doesn't make any sense because you would already have no duplicates if you use the set semantics. You already have no duplicates in the first table, and the intersection is not going to create any duplicates, right? So only the union can create duplicates if they appear in both tables. For whom is that clear? All right. Okay. Who found it easy, right? You just have to remember union, intersection, except. That's how you compute this on two tables. So now, SQL is a very powerful language. You can do a lot of things with that. And what I would like to show you is that it's like a Lego game. That's a Lego game presentation. I want to show you that you can put queries in queries in queries in queries to build more complex queries. For this, on the high level, so that you understand this on a high level, just like in linear algebra, you have to distinguish between vectors and scalars in a vector space. For example, if you consider three-dimensional space, You have the notion of a vector and you have the notion of a real number, right? And a real number is not the same thing as a vector. It's the same here. It's the same thing here. We have tables and we have scalars. Scalars are the atomic values, right, that you can calculate with. And the tables are the structures, right? So just like we have vectors and scalars in linear algebra, in the relational algebra, we have tables and scalars. And so if you want to combine them, you basically can turn tables into tables and values into values, so that we've already seen, right? But in fact, if you really want to think of all possible combinations, then basically you could have an expression that returns a value, a scalar. Scalar value is the same thing. So a value expression in a value expression, right? That's basically 1 plus 2 times 3. That's an example. You put 2 times 3 within the 1 plus. Or you could put a value expression into a table expression. That's what you do when you have the select clause. You put formulas that you want to project on, right? Or you put a table expression into a value expression that we haven't seen yet, but you can actually do that, as strange as it might seem. Or you can even put a table expression into a table expression, right? So it's kind of what we did already with union, intersect, and except, right? We already combined select from where into bigger things. But let me go through them to give you examples of that. The easy part is value in value. Value into value, that's just standard mathematics as we do it in primary school with arithmetics, logic, and so on. So that's an example of something you could see in the where clause, where we have here an expression that's, you remember, the double vectical bar is the concatenation of strings, so that would be the string 34. Then cast as big int turns it into the integer, the integer 34 on 64 bits. And 2 plus that gives you 36. Who agrees this returns 36? Right? So this is just a fancy formula that computes stuff with scalars, with just atomic values, right? And you can have that in your select clause. You can have that in the where clause, for example, in the having clause. So these are all values expressions that return values expressions. Okay? So that's the easy part. That we've seen before. It's not surprising. Now, nesting value expressions into tables expression is exactly that. The moment you put it in the select clause or in the where clause, you see that is a value expression, just like this one here. So you can put it in there. You can also put them in here in the where clause. And what we've done, and we did it last week many, many times, we have put value expressions in the predicates and in the projections inside the table expressions. Who agrees? Okay, we've seen that that is absolutely not new for the moment, that we put value expressions into table expressions, right? So that's value expressions that we put into table expressions. But things become quite exciting and advanced when you want to do bigger things. For example, what if you have these 4 scalars, foo, bar, n1, and 2, and you want to put them in a table 2 by 2? How do you do that? Well, actually, you can do it in several ways. So first, you could take a scalar expression. So here I just put 1, but instead of 1, you can have any expression you want. Select 1 as A. There is no from, nowhere, just the select and the as to rename it. Select 1 as A. So we can turn a scalar into a table with 1 row and 1 column, right? So that's the first thing. We could also use just a select clause with multiple values. So select James and 22, 23, and I just give them names like name and date, right? So now I've created a table with just 1 record and multiple columns, right? Who understands this query, right? It's just a select from where, but without the from and without the where, right? It's just a simple select. But the problem of that is that you can only create 1 record. So how would you create a table with 10 records then? What could you use if you use a select like that and you want 10 records? Something I shown you just 5 minutes ago. Do you agree you could use a union, right? You could do select 10 times and union, 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 union. Who agrees with that, right? But that would be very cumbersome. So we have something better. We can just say values like this, a list of records like this or like this, right? Who remembers we've seen that before a few weeks ago? Do you remember we've seen then in the insert into statements, insert values into, who remembers that? Right? Well, this is what it is. It exists on its own. It doesn't need to be an insert into. It can also have its own life. The values can be in the wild, right? It's like this. Okay? So this is how you can basically take, in that case, 6 scalars, 6 atomic values, and turn this into a table of 2 columns by 3 rows. Okay? Now, something fundamental is that values and select go in the same places. So whenever you have somewhere a select, you could replace it with the values. And whenever you have values somewhere, you can replace it with a select. Examples. When I show you the union example, here I showed you union, right? Well, technically, you could replace the select with values. You could have values and values, right? So select and values are interchangeable. And another place, in the insert into blah, 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 insert values into, you could also replace the values with a select. You could also have insert select from where blah, 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 into, right? So basically, these two have basically equal status in SQL, right? They go to the same places. They are just table expressions. They are just expressions that return tables. Who is still with me? Right, very good. So take a good photography of that. Of course, when I say select from, it's everything. Select from, where, group by, having, order by, limit of sets. Okay. Now, let me go back to this one. I told you with a single, sorry, too far away, you can turn a single atomic value into a table with 1 row and 1 column. Turns out that also goes the other way. It means that if at some place you expect a single value, then you can basically do it the other way. You can basically put a table that could be a select from where, but if that select from where returns a single row, a single column, then PostgreSQL is able to basically unbox it into just the value, right? So, for example, you could have a query, so that's a query that finds the maximum warp, right? There's no group by, so it just takes the max of the whole table, maximum warp. Do you agree this returns this? Who agrees? Okay. So now you notice this is 1 row, 1 column. We just have this 9.975. It means that I can basically put this select max warp from spaceships inside a value expression that normally would expect a single value. Here it's a multiplication. I multiply single numbers, right? So I can put that select max warp from spaceships multiplied by this. This is going to extract that single value that there is in my table and multiply it with this 1.001, right? So if I do the multiplication, I'm basically getting 9985. And then you can put it inside, again, a select statement. So basically here we have a table in a table expression, in a scalar expression, in a table expression, right? For whom does that expression make sense, right? Okay. So I have a select in a multiplication in another select, right? Okay. So you start seeing the power of the sort of things that we can do. Here's another place where you could use it. Imagine in the where clause, you have this max, and you would like now to select the records that have this value, that have the maximum value. That is called an argmax. Who already heard argmax in mathematics? The argmax is basically the value that leads to the maximum. So if you want an argmax, you just compute the max, and then you put it in a where clause with an equality, and you're looking for the spaceships whose warp is equal to the max. And that gives you the argmax. What we've done is we've again put a table expression inside a value expression, inside a table expression. Right. Just like Inception. This is really what's going on here. This is yet another way of having a table expression in a value expression in a table expression, but this time it's not a single value that it returns. Select name from persons might return, I don't know, 1 million values. But there is this in, captain in, blah, blah, blah. And so captain in is just saying that it's true if it's in the list. So this is going to basically look for the spaceships so that the captain is in the list on the right. Right? Who sees that? Okay. So we've again put a table expression in a value expression in a table expression. Who sees, that's bonus, advanced question, who sees that this is kind of half of a join? You're kind of joining the table of the spaceships with the persons, but you're only keeping the spaceships part, the spaceships that would match the persons. Who sees that? Right? That's called a semi-join, right? So, okay. So the in is very practical when you want to check as a predicate, as a selection predicate. You would like not to check for equality or for lower than or greater than, but you would like to check if it's in a particular list. Okay. And now, even more complicated, a table expression in a table expression in a table expression in a table expression. So it means a select in a select in a select in a select, right? And how can you do that? Do we have a question on Zoom?
Yes.
Awesome.
Could you tell how to differentiate value in table expressions? I just want to see whether my understanding is correct.
So what I call table expression is whatever starts with select or with values. Right. So for example, this select name from persons, that's a table expression. This select captain warp from where, that's a table expression. They basically return tables, right, with plenty of rows and columns. What I call a value expression is basically an expression that returns a single value, an atomic value. It's just a string, just a number, and that's what I call value expressions. So value expressions includes addition, multiplication, division, comparison, logic, exponential, trigonometric functions, string concatenation, and so on. These are all value expressions, right? So on the one hand, select from where and values that are table expressions. And on the other hand, everything you can do with single atomic values that are value expressions, right? And so what I'm showing you right now for a few minutes is how you can put them in each other. You can basically put a table expression inside a value expression, or a value expression inside a table expression, a value expression inside a value expression, a table expression inside a table expression. It's a Lego game that I told you about. When you play Lego, you can also assemble that in any way you want. Does that answer your question?
Yes.
Yeah. Thank you. All right. We have another question over there. That's a very good question. And I have an example, just one example of that earlier, and I will have another example later. So here you would specify the names. If you use just a single select without a from, you can specify the name. If, however, you don't specify anything, then the system is going to come up with names for you, basically just going to make them up. So in that case, I think PostgreSQL is :1, :2. It's not very original, but it just comes up with names for that. So you just need to be aware of that if you don't specify anything, then the column names are completely arbitrary. Well, now, if what you're doing with values is insert into, then it doesn't matter, right? Because you just care about the values. But what if you do want to have the names? Well, I have a slide. I can actually already show it to you. Just close your eyes on what comes in between to not be scared. Oh, it's actually right here. So if you do want to control the names, then you put the table expression inside the table expression. You put the values inside the select, inside the from clause of a select, and there you can rename it, because we've seen in the from clause you can use as to rename the name of the table and not the attributes. And now we have a table persons with name and date. Oh. Yeah, I'll commit. Oh yes, I will also do that. I just realized that I made a mistake on the slides because you see that I renamed the columns, but the names are not shown. And then I will repeat also the question that I forgot to do. So I'm just reprojecting this, but now fixed, which is coming right up. Where is it? Right here. So now I have fixed it. So now you see it's correctly saying name and date here. I should apparate, yes, name and date. So the question, so that I repeat, was if you just say values, the question was if you just say values, what are the names of the columns then? Because in values, you just specify the values, but not the columns. And so what I said is basically that PostgreSQL just comes up with names for you since you didn't specify. And I think by default, it just says column 1, column 2, column 3, column 4. But you should not assume anything. The types are inferred. It just looks at what you said, and it inferred that the first one is text and the second one is also text because you didn't specify that it's a date. Okay. All right. So does it answer your question? Yeah, awesome. And on Zoom, that's okay too? No other questions? Okay. So actually, I was just 2 slides away from that one. Okay. So basically, I'm showing you tables in tables, table expressions in table expressions. And so you can put a select from where inside another select from where. We've already seen that if you put the select from where inside the select, so that we've seen. We've also seen a select from where it's inside the where clause, and here too. And now we have a select from where it's inside the from clause, right? So you can see it's a very generic Lego game. There's many, many things you can do in this way. So here you just select from a table that you've just computed instead of selecting from a table that would be on the disk. Who is with me? Right? And of course, you can rename. Also, you can rename with a select, or you can rename on values, right? It doesn't matter what you have inside. By the way, this is another example of where you can have select or values at the same place, right? They are completely interchangeable. Do we have questions on Zoom?
Yeah,
which slide?
Discussing which correction did you do and what slide?
Oh, what correction? Let me tell you, because
the name of the column.
Yeah, it's just the names of the columns. I basically just noticed that I put that slide and I forgot because it's a new slide. It wasn't there last year. I just added it to explain more. And so I forgot to change. It was still written column 1, column 2. But of course, since I do rename it with this as person's name date, then I should see name and date in here. Right. So I should see the correct columns. I could even have put persons in the black part. Okay. Everybody with me? Yeah, Zoom too? Okay. Now, here's another feature that can be very useful in the exam when you have a few more complex query is the with clause. The with clause is just a way to decompose a more complex query into multiple queries. And what I mean with that is that if you write queries like this, you might end up with a select from where, in 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 a select from where. And as you can imagine, it's becoming hard to read when you start having multiple levels of nestedness. And so the with clause is just a way to make it more readable. Instead of putting the select inside the select, inside the select, inside the select, you just give them names. So you basically say your first select, you call it average salaries, and then you use that average salaries, right? So that's the same as if you would have the select from group by inside the from, but to make it easier to read for a human being, you just put it first with a name, and then you reuse it with its name, right? You can have chains of that with select, comma, select, comma, select, comma, select. So you can have plenty of a whole chain of tables computed from each other in that order. And it's just, you know, it's as if when you have a mathematics assignment in high school, you don't just drop a gigantic formula, right? Instead, you give names to intermediate results, right? When you write programs in Python, it's the same. You have intermediate results, you put them in variables, and then you reuse the variables, right? You don't write a program that directly has this huge line that no human can read, right? So this is what intermediate results are for with variables. Who is with me? Right? So again, the with clause is really only a convenience to make it easier to read by humans by giving names to intermediate results. That's what it does. But wait, there's more. Because, and that's really advanced, and we are not going to push it that far at the exam, but just so you know. Oh, there's a question?
Yeah. Could you also use this as something akin to a variable and temporarily store values this way?
Yine, basically it's functional. That's not declarative. So the width is not actually assigning it to a variable in the same way you would do it in Java, in Python, and then later you can see the value. This here is only a binding. So this AVG salaries, it's only going to exist for the duration of that query. So you can use it in the select from after that, but the next query will no longer see it, right? So it's really a temporary assignment. So it's very important to understand that this is a functional language and not an imperative language, right? And if some of you know, who knows F# or OCaml or Haskell, these languages, do we have a few people, maybe some of you on Zoom? So if anybody knows functional languages, then this is kind of the things that it means, right? So this is not an actual variable assignment. It's really a functional way of doing that, right? The difference is very subtle. Just think of it as a temporary thing that doesn't survive the query. Did I answer your question? Yeah. Okay. All right. And then I added that because it's Halloween, so I needed to scare you. We also have recursive with clauses, just like you can have recursive functions. So basically what it means that it's recursive is that you define this table that I call temp, referring to itself, right? So it's just like this strange loop in here. And so the way you do recursion is always with a union or a union, or you basically, that's the initialization of the recursion right here, where you start, like it's computing factorials basically. So you have 0, the factorial is 1, and then you go one step more. You basically add +1 and multiply it by the previous fact, and we stop at some point at 9. So this is going to output a table that contains the factorials, so in the number in the first column, the factorial in the second column, all the way from 0 to 8. Right? Sorry, to 9, because n equals 8 here, but it's going to be 9 when you do n+1, from 0 to 9. Right? Who is with me? Who already did that with the Fibonacci sequence? That's what they use when they teach recursion. Whoever implemented the Fibonacci, yeah, Fibonacci numbers, that's the typical thing you can do. I could actually have done it with Fibonacci too. You can actually try as an exercise. Right. By the way, you can copy-paste that into a Jupyter notebook. That's going to work if you want to see what it does. Okay, but don't worry, we won't have recursive at the exam. It's just to show you the sort of things that you can do with this. All right, so now just to see, do I need to slow down? Do I need to accelerate? Do I need to take more time to answer questions, online, offline? So I'm referring here to the entire SQL lecture, right? Including what we did last week. Do you understand the select clause, the from clause, the where clause? Do you understand how group by works? Do you understand how you can order tuples with order by? Do you understand how to use limit and offsets to paginate? Are you able to join tables? Do you understand how to do an inner join, an outer join, how to make the join natural, or how to specify a predicate with on, how you can compute the unions of tables, the intersection of tables, set subtraction of tables, and then how you can turn it into a Lego game by putting expressions into expressions. Okay, so maybe if I wanted to refresh, I might need to press a button because I see that it's not refreshing here. That's strange. Do I need to? That is very strange. Doesn't seem to be. Maybe I can reset it.
That is only the previous question.
Let me see if there's any way. If I say clear. Oh, now? No, that's another question. So let me say clear results. Okay, so clear results. And now, can we try again, maybe? That's annoying, and I have absolutely no idea what to do in order to change that. So what happens on when you go to the page? Can you answer, or is it just that it doesn't?
Yeah.
Oh, it's the previous question.
Yes.
Ah, okay. It doesn't show it correctly. What if I click again like this? Otherwise, I'll try something else. If now I go to Zoom, I'll leave it during the break. Yeah, oh, see, it seems that now it is working, right? All right, so let me just project it, and then we'll have the break, so you can continue to answer during the break. I really want to make sure that I understand if I'm too slow or too fast. So thank you very much, everybody. I'll see you in 15 minutes. We'll start with the database design theory after the break. This actually looks good, majority above 80.